Okay, in January 2011, Samsung Group announced the Samsung Eco Management Vision 2020. Its commitment to green management. The vision of 2020 includes our investment plan. Samsung's Electronics is dedicated to pursuing its Eco Management in 2013 program that was initiated in 2009 and has strengthened green management efforts at group levels. Green management at Samsung Electronics includes a wide range of activities such as Samsung operates, I believe, and the Green Management Committee persuaded by the CEO. So it is reasonable for the company's green management as a whole by setting the green management vision and midterm objectives under the Green Management Committee. So please welcome Dr. Nareen. Please, thank you.
Good afternoon. First of all, I'm not a doctor. Secondly, I'm coming after a very powerful technical presentation. I have to admit, I'm not a man from the industry, but I work for a company where, as was mentioned, green management is something that is practiced across the globe. Work for Samsung Electronics in the Gulf region. I head the enterprise business, and we were just discussing during the earlier presentation about basically how the previous presentation and talk on sustainability is so relevant to what probably I'm going to be talking about, and it extends within an infrastructure. We talked a lot about massive projects of areas where we need to focus on sustainability, but it also goes into a lot of our products which help in achieving something within a project, within a building. So that's what Samsung is focusing on. A lot of technologies that we develop are all pretty much eco-friendly. So I'll quickly run through the various initiatives at Samsung and touch upon the products and where we stand today in terms of green management at Samsung. So this is something that we firmly believe, as mentioned, driven by our global CEO. So we definitely look at people, society, and the environment. This is most critical in Samsung. In terms of social contribution, we do this across the globe, but what is relevant in the Middle East is, for example, we make huge contribution to the handicapped children community. So we are very closely working with El Noor here. We're expecting to expand it to other countries in the region also. Business sustainability. Now, these are the 5 pillars on which that we focus on. One is reducing the greenhouse gas emissions. 2 is indirect greenhouse gas emissions from the Samsung products, to reduce that as well. Have good eco products. We want to achieve 100% in our product lineup. Investing, continuous investment is required. So we are investing an estimated little over $4 billion as we speak, which will go up to 2013 in terms of eco management initiatives. That's very important. And cooperate with our partners, with our suppliers. So that is very, very critical, because our products, a lot of them are made with partners delivering us components to build our various gadgets. So we need to cooperate with them. So we have to extend what we practice to them too. Some of the eco-friendly products, just to get a quick glimpse, LED TV, LED technology is something that Samsung pioneered. Samsung is known for LED, and that is something that is continuing, coming out with newer technologies within LED itself, helping in vast reduction in energy consumption. Then we have the EcoBubble washing machine. Most of you would know about it. We have SmartFlex Duo ovens and memories. Samsung is known for memories. This company was born out of building memories, growing the wafers. So we have memories which help in reduction of energy consumption. Quick highlight of the company globally, just to basically bring to the table the fact that it's a very, very large global company. It became #1 as the electronics in the electronics industry. Despite the hugeness and size of the company, green is something that is talked about literally every other day. So we were at $135 billion as of last year. But what is important is we were ranked number 1 in terms of carbon disclosure. So that was very, very critical, the Carbon Disclosure Leadership Index. We reduced greenhouse gas emissions by 31% in 2010 as opposed to what it was in 2008. We came out with one of the most appreciated and admired gadgets, the smartphone Galaxy S. Then we have 37 products which won the Innovation Awards in the CES show in January. So that's the company we are talking about. We have, as we speak, 2,210 eco-friendly products. If you look at a survey done across 219 electronics manufacturers, we lead the pack with 2,210 eco-friendly products that we have. And then we are very much there in the Dow Jones Sustainability Index, within the top 10. For the last 2 years, we've continued to be in that. We are one of the top, in the top 100 in terms of global sustainability as a company. We have launched, probably for most of you who may not know, we have launched the first medical device, a blood tester, which is into our foray into the healthcare business pretty recently. And we have got, as I mentioned before, we have partner firms which supply us various products. We have basically aligned with them and made them follow the standards for sustainability. 662 of these partner firms are currently very much in line with our direction. In terms of structure, Samsung Electronics has got basically 8 business units globally. Visual display, the display that you see out there, that is one of the units. It also takes, looks after TVs, large format display screens, interactive displays, touchscreen displays. Then we have the IT solution where we have laptops, printer, imaging and printing. We have storage products, and we have displays for businesses, digital appliances, mobile communication network, digital imaging, semiconductor, and the panels. Global network, we have 199 subsidiaries globally, manufacturing production, which is production plants in various countries. We have sales subsidiaries, distribution subsidiaries, and R&D centers globally, spread across the globe. As far as green management is concerned, I don't want to repeat what was said at the very beginning. This is something that is practiced very sincerely, and we are very much on course to achieve certain set objectives by 2013. It was part of our 5-year plan starting 2009. This is when we set about practicing. In 2011, we drew out our plan for the next 10 years, the 2020 vision, as they would call it. And in this, what is most significant is the continuing investment that is going into green technology. And that investment is massive in terms of R&D to come out with products including solar cells, rechargeable batteries, and for vehicles as well as LEDs. So this investment is going to be in excess of $20 billion US. So that's a massive investment and a commitment, part of our Vision 2020. In short, as far as green management is concerned, in this particular slide, though it's not highly visible, but one important point that comes out, which is practiced, is basically creating new value through eco-innovation. Now, people have been talking about innovation, but what we talk about within Samsung is new value through eco-innovation, and that basically drives the emphasis and focus on green across all our businesses. We have won the Eco-Friendly Award recently. We achieved 19 green awards in the year that passed in 2010. We expect to have more this year as well. As far as eco-design is concerned, this is a process that we set forth in 2004, basically carefully managing our processes across our production base, across our R&D facilities to ensure that we achieve the set objectives of having more and more of our products eco-friendly. As mentioned, we want to be 100% eco-friendly across all categories of our businesses. Now, this basically is a slide which focuses on Samsung meeting the global environmental standards consistently, and it also talks about energy efficiency across all of our products. So this is something that we have achieved, and we've been recognized for this globally with multiple awards. So as you can see, we were awarded the Energy Star Partner of the Year. Now, this is a certification that most of you would know, and that has extended from the very first products that we manufactured to today, some of the recently new technologies that we have announced, and we probably will be one of the few companies which have got eco products across all the categories that we have with Energy Star certification. Part of also our sustainability initiative is to look at other aspects. So we have strategy very clearly which is focused on the greenhouse gas emission. So we have achieved our target. We have been able to reduce this from 2009 to 2010. Energy consumption. So we have basically the LCD business has been awarded as the only company in Korea by the Korean electronics industry. It has got the Korean Energy Management System Award. So this was achieved. This was a significant achievement. And the same business unit, LCD business unit, also was recognized for the Clean Development Mechanism. This was a project that was initiated in 2010, very successfully driven. The semiconductor business has got the carbon labeling certificates, memories which go into literally every single digital gadget that we see in the market today. Apart from that, there are huge initiatives in terms of resource recycling and reuse. We have implemented this across multiple countries globally, including countries like India, where we have locations where it enables people to turn in some of the gadgets, like for example mobile phones, and this is then used for recycling. I already spoke about product resource efficiency. So this is basically highlighting our STAR program, voluntary collection of the mobile products that I spoke about today, so very much focused on recycling. Water management, I don't want to go deep into this, but this is very much in the heart of Samsung. Due to the very fact that we have production facilities globally, this is a key focus area for us to ensure that we follow the guidelines to manage a very green environment. Water reuse, toxic monitoring system. These are all a lot of heavy slides with a lot of key KPIs or key performance indicators, so I don't want to go deep into this. But basically the message that we have is have a global green workplace wherever we are, whether it's a sales subsidiary or a production subsidiary or it's an R&D center. This is what we basically are prescribed to follow. In terms of obviously the initiative post the Montreal Protocol, ozone depleting substances, these are continues to use, Samsung uses ozone depleting substances, and it has been definitely seeing a downward trend since 2007. This is basically some of the messages that are communicated across the globe. So we have a global green communication cell that monitors this very, very carefully. What I want to quickly touch upon is some of the products. So we talked about one of the divisions is the IT solutions, where we have printing and imaging. And printing and imaging, many people would know, if you go back, let's say 5-10 years, was one major area of concern, particularly because of the inks and the toners and the recyclability of these. So this is one business where we have start to finish designing, producing, distributing, customer usage, and recycling. The end of life is very well managed. So across the board in our imaging and printing business, we are very much green. Then I would like to skip this and move quickly on to another product line, which is the large format display screen. Now what you see right across this room, we have a matrix solution, a video wall as many people will call it. It's a 2x2 video wall of large format display screen. which used to be LCD. We have now moved to LED. So we have already announced it. These products have been launched. So we have moved into LED technology on these screens. And what you get out of that is precisely lower power consumption. Basically, as you know, we have also carefully looked at avoiding mercury, avoiding lead, spray-free. So this is a very clear move in the right direction in terms of offering customers and consumers products which are eco-friendly. Obviously, the LED technology, as most of you would know, means reduction in energy consumption. So you could see the numbers out there, resulting in cost savings too, to almost 50%, 48% to be precise. Less heat from the panel with an LED technology, so less cooling energy that is required, again, resulting in cost savings. Notebooks. We have green notebooks too. So we are probably the only manufacturer globally which has got the TCO label across all the notebooks that we have, including the latest notebook that was launched. Actually, the notebook is in my carry bag. I wanted to show it to you. It is the lightest form factor that is available globally. All of these notebooks have the TCO label in them. So we are probably the only manufacturer globally. So I thought I should highlight it. And then the air conditioning part of the business, my colleague is here, Adnan. So he said we need to talk about the air conditioning business, where again we are pretty much right at the top of the pack in terms of following green technology. Adnan, you want to mention something about the standards that we follow?
In fact, we're promoting the DVM system. That's our VRF system, where our system is high in efficiency. The COP at high ambient conditions goes from 3.4 to 4.4, which is absolutely the highest in the industry. We use the 410A refrigerant in that system, and we have been approved, especially here in Abu Dhabi, and listed at the UPC. I mean, we have more details on our stand. If you want to visit, we can give you more details. Thanks. Thank you.
And finally, in fact, we would be shifting our premises in Dubai. We're shifting offices. And coincidentally, one of our largest partners here, most of you may know in Dubai, Eros Electricals, they're moving into a new building. And between us, we have agreed that either of these two new premises would be completely green with the green technologies of Samsung. So it's something that we speak about all the time. We live and we want to be living in a green environment. And I also want to take this opportunity. A lot of people have come, a lot of customers, a lot of partners, good friends who would have come here and dropped their cars. And I thought it was only apt that I was speaking to the organizers and said that I think I should use this opportunity. We want to, I hope people have dropped their business cards. We want to do a lucky draw and offer a green technology notebook with a TCO label. So I thought I should use this opportunity to announce that. So we basically live green, want to think green, and we will be green. That's where I want to end my presentation. Thank you very much, gentlemen.
Thank you. I see there's a lot of vast products in coming up in the new technologies of development. And it's good to know to keep us on the cutting edge of what products that are out there, because then it changes some of the design curriculums and the construction activities that are happening within MEP. And I get a lot of those challenges now on Mazda projects. So thank you very much. Thank you. For any questionings, you have a question, huh?
I know you don't want me to ask too many questions, but I just have a question regarding the emissions that you mentioned, emissions per sale. What's the unit over there? Is that per dollar of sale? You have 5.3 tons of CO2 per sale. Is that per dollar?
Yeah.
So, and your sales are $150 billion, you said?
We are 135.
And what's the benchmark for that figure?
See, currently, to be honest with you, I wouldn't know the benchmark. I need to check on that. But yes, 135 is the current revenue.
Please, no questions that'll stump our speakers, please. He'll have it soon. You know what we're going to do is we're going to have one more speaker, then after this, We'll take a coffee break, and then we'll finish out the day with the other two speakers. Next, I'd like to choosing the right refrigerant with Mr. Alexander Ward. Mr. Ward has, I don't know, since a long time. Mr. Alexander Ward is a graduate of Stephen Institutes of Technology, where he obtained a degree in mechanical engineer. Upon graduation, he began his career with Westinghouse Electric Corporation Division, which eventually was purchased by McQuay International. During his career, he has held the positions of product manager, marketing manager, business unit manager, vice president, and general manager. Just basically climbed the corporate ladder. Mr. Ward has had numerous paper publishing on chillers, chiller systems, all throughout within ASHRAE, and he's a member of AHRI as a chairman with liquid chillers. Please.
Thank you. Okay, I would, good afternoon, ladies and gentlemen. I would like to address the audience and look at a perspective of what's going to happen to the next generation in terms of refrigerants and how we look at it. And to start off, let's see if we get all the equipment working here. To give you a little bit of background on why we're even looking at new refrigerants, we're going to look at what are the future options and how we evaluate those options, and then give you a little a glimpse at what the refrigerant map will look from very small units up into the very large ones, and then draw some conclusions. Some of the background, this is the problem that hasn't been corrected. If you look at the green line, this is the emissions in gross tons of CO2 going up this way versus years this way, and you can see it's continuing to increase. And two things are causing that. Is the more the world is developed, and more buildings are going up, and you can see development even in Abu Dhabi, it's causing an increase in the emissions of CO2. Now, CO2 is being emitted in direct and indirect. Direct means would be the emissions, where the indirect would be the actual power used to power, let's say, an air conditioning unit, and then that power is provided by a fossil fuel plant. So we have to do two things. We have to look at how we design buildings, and that's the job of the architects and the engineers. And then us as manufacturers, how we provide equipment with as energy efficient as possible and utilizing the right refrigerants that minimizes the effect on CO2 emissions. So we have a problem here. If we keep on letting it go unchecked, we're going to go way up here. We have to lower it to 550 parts per million, and at best try to get it to 450 so we actually start decreasing. The world is actually, you can look at the world from a usage of air conditioning and heat pumps and different categories. Far north you have heating, in the middle heating and cooling. Where we are right now, cooling only. The key point of this is everybody thinks of air conditioning, and typical of this market would be a cooling only opportunity. But if you look at the heating and cooling areas, you'll find that most of the heating is provided by fossil fuel. And just taking a majority of that and changing it over to heat pump versus using direct fossil fuel could have a reduction of about 8% in CO2 emissions. So, have we done this before? Have we able to solve this problem in the past? And the answer is yes. If you go back in the early 90s, we had a problem called the ozone depletion layer. And we were pumping into the atmosphere ozone depletion substances, like basically CFCs. We put a program together between the consultants and the manufacturers and the suppliers. We got together and developed substitutes, and basically through the Montreal Protocol started the process of banning those refrigerants. And the results is very, very good. You can see here where the Montreal Protocol impact started, and we basically reduce the emissions of those CFCs. And basically what's out there now is just the installed stock. Nobody's using it anymore. And if we didn't do that, we would have been way up here. Now we use these substitutes, which are the HCFCs, and now we're starting to have them become a problem. And then we're going to have to address this now. We can wait, but as we wait, the further we wait, the worse it's going to get. And the problem presents itself here, basically for our industry, it's the light blue and the dark blue, which goes into refrigeration and stationary air conditioning. You can see this could be the emissions in metric tons of these refrigerants, or if left unchecked. So we have to do something about the emissions here of these refrigerants and in order to lower the overall global warming impact. So how are these refrigerants in comparison to what might be available? And herein lies the problem. The Montreal Protocol took care of this problem here, which is the ozone depletion potential. We've got rid of CFC 11, 12, 500. They're all gone now. All that's left is R22, which still has a very small amount of chlorine that can get released into the atmosphere. Our problem here now is this column, the global warming potential of these refrigerants if released through emissions to the atmosphere. R22 is high, R410A is high, R407C is high, R134A, which we forgot to put on the charts, about 1,400, so that's relatively high. And then we come down into possible alternatives, which is R32. It's 675, and then HFOs, which would be replacing the 134A, which are very, very low. And then we get into what is natural refrigerants, CO2, ammonia, and propane. So we'll do a little comparison here and look and see how all this applies to typical air conditioning today. Give you an idea, we did a pretty good job in doing a lot of the conversions. So we've done this before, and we can do it again. We do have the technology, and it isn't as hard as everybody might think it is. You know, we look what happened back in the 90s. We took all the CFC designs and converted them over to 134A. Not a major issue. In the R22 designs, we initially converted them over to 407, which was a basically drop-in substitute, until the R410 designs could come out that could handle the pressures of R410, but that's basically all done now. So that went very smoothly. Hydrocarbons still become an issue because of the safety concerns. We'll talk about that a little. And then CO2's never really hit it off the ground for various reasons, and we'll get into that. R32, we stopped the development of that because we had a solution with 410. And now we need to look at it again because of the global warming. And the HFOs are basically new on the map, and we'll be looking at those to convert over from the 134A. So how to evaluate refrigerants? Well, the first one gets back to the first slide, is if a third of the energy consumption in the world is for buildings, and part of that building is your air conditioning system, then the energy consumed by the air conditioning units, whether it's small window units for residential or all the way up to big chillers, is of prime importance to us. So if we look at, this is just a simple slide, and this was done for a 3.5 kW room unit, and it's for Europe. But what we looked at is two comparisons, seasonal energy efficiency and peak power. Probably we're more concerned with peak power in this part of the world, but what we looked at is the R22, which is a baseline, is about here, and the further off you go in this chart to the right, the better off you are. And it looks like one of the substitutes for R22 is the R23 or R32, and it is actually more efficient than the R22. So in that category, it looks very good. 410A is about the same as 22, but the one that really stands out as a problematic is CO2. So it would not be a choice if you're looking for seasonal energy efficiency. peak power, which should be a big concern in this part of the world because it also reflects on a hot day in Abu Dhabi at 50 degrees or 46 degrees C. You're putting stress on the grids, and you want to minimize that stress. So here on a peak power, everybody's about the same here except for CO2 again. CO2 presents a major problem on peak power. So the application use of CO2 is starting to fade away, whereas we still can look at the 32 and the HFOs as possible substitutes. The next thing to look at in the designs of these products is how can we lessen the amount of emissions of these new refrigerants. Besides the refrigerant itself, what can we do? One of the major things to look at is how we design a product and the amount of refrigerant we use in that product. There are ways to design products to minimize the charge. And it takes a little different thinking, a lot more engineering involved. But if we were to take a typical system of, let's say, R22 or R410A, and these are the global warming potentials of 1800 and 2090, and let's say we took a R32 system, which starts out with a much lower global warming potential, and then we reduce the charge by 40%, we could reduce the global emission rate by 80%. So not only do we have to pick the right refrigerant, we have to look at the design of the equipment to minimize the charge. The second thing to look at in picking the right refrigerants is the safety classifications, and this bears notice because there is a slight issue with the new refrigerants that have to be addressed. We're used to dealing with refrigerants that are basically categorized as A1 or Class A1, which is basically safe refrigerants. As we move to 32 and the HFOs, they're classified as 2L, which is slightly flammable. So understanding what that is and how you design your equipment is critical for the safety of our customers and our basic safety of our customers, as compared to Class 3, which would be propane, which is highly flammable. And we've had issues throughout the world, a lot in Australia and New Zealand because they've been promoting propane down there, but there's been a lot of accidents, mainly because of the misuse of the product and people not really understanding the potential it has for safety hazards. So in designing systems and understanding the effect of what is an A2L refrigerant, you look at basically 4 things you have to examine, which is the lower flammability limit, the burning velocity, the heat of combustion, and the minimum ignition energy. And you have to take that excuse me, all into account in your design to ensure that you are providing a safe piece of equipment. Okay, this is an interesting slide in the sense that it shows you what's happening in today's market. If you look at the developing nations, there are many developing nations that have not started the conversion of the HFCs over to non-ozone depleting substances. It's nice to see that most of the countries here in this area of the world have already bridged that, and they're not using any HCFCs to any great extent. The issue, though, overall worldwide is that the HVAC market in the developing countries is growing very rapidly as compared to the developed nations where we've already completed the changeover to non-ODS substances. The markets are saturated, but what happens in the long run, if you look at the emissions potential, the developing countries far outweigh the developed countries because of the use of refrigerants and the containment practices that are in place in the developed countries versus non-developed countries. So there's a need to educate and bring up the developing countries to a point where they're adopting some of the practices in the developed countries so we can get a quick gain on this problem and reduce the global emissions. So if we look at a map of where everything is, this is where we currently are with refrigerants. We have capacity from the very smallest up to about 1,000 kW where we're using R410A, and then above 1,000 kW we're switching over to 134A. And so that's what's basically available in the market today. So now we start looking at systems. What could we use? One of the choices that we're looking very hard at is 32. It basically performs better from an efficiency standpoint than 410A. It also performs at high ambient conditions, which is critical for this part of the world. And we have to address the flammability, mild flammability issues in accordance with ASHRAE and ISO standards. So it would be used as a substitute for 410A. On the higher side, the big equipment that we'd see in district cooling plants and the big buildings around this area, they're going to be HFOs, and it'll be either dependent on the type of compressor that you might select. It'll either be the 123YF or the 1234YE, and there's some others being that are being reviewed that are not for publication yet. So we'll see all that type of product move to that refrigerant. CO2 becomes extremely limited, particularly in this area, and if you look at where this chart or graph lays off, you'll see that we don't see CO2 much above 25 degrees C. If you look at condensing temperatures in this area of the world, you'd have to be way up here. And one of the problems with CO2, not only efficiency, but the cost of the product because of the pressures at these increased temperatures would be basically prohibited. So what you might see in CO2 is heat pump water heaters, or in the colder climates you might see a version of a heating system using CO2, but I doubt if you'll see any CO2 air conditioning systems, particularly in this part of the world. And again, the HCs, which is your propane, because of the safety considerations, the amount of charge in a system has to be absolutely minimal, which will really bring it down to very, very small pieces of equipment and really not applicable to any larger size pieces of equipment, mainly because of the safety issues.
And when probably cars were invented and made, and they kind of just spread all around the world, and it's probably one of the most unsafe inventions, for example, compared to airplanes. So why is it when it comes to refrigerant, we're so strict about safety that we completely discard certain very efficient refrigerants? So I'd just like to have your opinion about that.
Okay, I was trying to understand the question. You were asking about why we're taking so much time with the safety of refrigerants. I think it's the way these refrigerants are applied, and a typical building like this, we could be here, and the equipment room could be next door. If not applied properly, and you could have issues with, it dependent on the refrigerant and the flammability. You could have an explosion that could affect something, or you could have issues with asphyxiation, or, if typical refrigerants are some that are toxic. So I think there's a key point in all this that I think all the manufacturers and the chemical producers want to ensure the health and safety, above all else, of the people that will be around the equipment and also operating it. It's part of the, it's one of these rules that goes without even saying, so we don't consider it any other way.
We have one more question over here, and then we can move on. One more question, please.
Just a question on the use of replacing 410A by R22. R22 has been on for a long time, and one of the issues with using R32 is the high discharge temperature and discharge pressure. It's got about 15 to 25 degrees C above that of using 410A. And that's why the reason why 410A was developed, which is a blend that contains already R32. What's so different now that would make R32 acceptable in AC system?
Okay, I think the question was in regards to R32 about the high temperature limits. That is that is the same issues that we had with the 410A, and it was probably one of the biggest issues to overcome. It's still being worked on. You know, this is how we look at the future. The future is not here yet. So we are looking at this, and it's up to engineering to develop the right solution so you can take an R32 refrigerant and apply it in a climate like this with 46 or 50 degrees C outside ambient and still have the refrigerant that works and works properly. So there's still work to be done. It's continually undergoing tests in our labs and trying to solve these problems. I'm not saying, you know, this isn't to say that, you know, this is a total solution. This is just the direction that we seem to be going right now.
Thank you. That's it? Thank you. We're going to, let's put your hands together for him, huh? 40 years of experience. Can't beat that. Thank you, sir.
Thank you.
You know what? We're going to continue on through this because what we're running a little short. We want to get out through some time, so I'd like to bring up the next two speakers, and then what we'll do is we'll go for Carrier. We'll do a short little thing on them, and then they'll do awards for these gentlemen, and then there's other awards coming up with UNIP. So that's what's happening for the rest of the program. So, but I'm going to leave the best. For me, Professor Bassam. You can tell I'm trying to get my extra credit there. So our next speaker, Albert Heikel. Mr. Albert Heikel is he'll be talking about carbon footprint on the district cooling plant, centrifugal chiller. He's a leader with Trane, and he's one of the head of his industries in this market. Please welcome Mr. Albert. Thank you.
Good afternoon, gentlemen. Subject today is the carbon footprint of district cooling plants. Now, why we choose the subject? Because we have so many district cooling plants in UAE, and we have more coming. We have around 2 million tons installed, and it's important to look at how does it affect the environment. Now, we will start by defining the carbon footprint, then why we are measuring it, because we want to try to reduce it. And then we will look at the estimate, how do we estimate it, what do we look for, what are the major drivers, and based on the major drivers we will look what's the most important aspect to look into, and at the end we will look at how does it affect the environment and how does it affect your bottom line also. So what's carbon footprint? Now the idea, the reason we selected this subject is coming when we worked with Masdar on 2009. Their target is to have the most sustainable plant in the world, district cooling plant in the world. And they were looking for all kinds of creative ideas. We are, I'm working as with the manufacturer of a chiller. We had to do our job. And the job was to find out how we can reduce the carbon footprint of a plant. To do that, we start first by what's the carbon footprint? This is the total emissions caused by organization, event, product, anything. Now, how do we measure it? The easiest way to measure it is to find the equivalent in CO2. And now all of the industry moved towards multiple of CO2, of kilogram of CO2 or tons of CO2. So today, the ton of carbon, due to the recession, it was supposed to be around $80 to $100 the carbon traded in the market. Today it's at $15 because of the recession. It's fluctuating, but it is a tradable. You can go to a bank, and if your if you can get carbon credits, you can trade it in the market. An important aspect here, if we look at the Gulf areas, this information is coming from the United States Department of Energy. The information I got is 2007, but it is the same till 2009, as far as I know. Now, Qatar is on the highest list. It has the highest per capita GDP in the world, 55.4 tons of CO2 per person. Followed by the number 3 is UAE, number 4 is Kuwait, number 5 is Bahrain. Not far beyond Saudi Arabia is number 14, and Oman is number 19. Now, if we look at the figure of 2009 or 10, it looks quite similar. Still, GCC countries are one of the major, the highest carbon footprint in the world. As we said, why we need to reduce it, the carbon footprint? Because we have limited natural resources. If we continue to use the natural resources as we used them before, we need 3 times the resources available in the earth in the next 30 years. Also for the safety, for our safety, we need to reduce the use of the infrastructure, local infrastructure, and finally, it should make sense. At the end, there should be benefit from doing that. One of the methods used for carbon footprint is called life cycle assessment. It's used commonly in Europe and even in the US. Now, life cycle assessment looks at the product or the event from cradle to grave. It will take all the ins and outs. It means from the day you create the product till the day you dispose of it. It can take the raw material, the transport, the production, distribution, storage, transport again, consumption, and then at the end disposal. You need to take care of all the inputs and outputs to reach that life cycle assessment. When we look at a chiller plant, we want to look at the whole balance. So if we have a chiller plant, what are the phases? You have the construction phase, you have the operation phase, and you have the disposal phase. Each phase has its own components, inputs and outputs. So we need, if you want to assess the whole plant, you need to look at all the inputs and outputs, and this is quite a big exercise. Remember how many inputs you have and how many outputs. But at the end, we need to look at all of that and see which are the major ones. Now, with the exercise we have done, we found that part of the study was concentrated on the equipment used for the construction of the plant, materials, steel, copper, wood, the transport, because if you're bringing steel from China, the transport from China to here is considered as part of the carbon footprint. Now, on the operation-wise, the major drivers are water and electricity. Why? Because you consume all the time water and electricity. The labor is low because you need 10 people to run a plant with a 30 tons per year. It does not add a lot. Now, there is also the refrigerant emission as an output, because you have other things like water vapor, chemicals, cooling tower, but these, the value, the footprint of these items, the amount of carbon is low. The refrigerant emission is considerable, so we need to take it into our consideration. Then on disposal phase, again, the refrigerant emitted has to be taken into consideration. Part of the exercise is also on the chiller itself. You need to look at the construction phase, operation phase, and disposal phase. And it's similar to the plant itself. Now, the case study was done on 30,000 ton typical chiller in UAE. We used the most common configuration, which is 12 chillers in series counterflow, 2,500 ton approximately each. Each module will be 5,000 tons. No chilled water storage because at the time most of the plants built before did not have any water storage. The open cell cooling towers and primary and secondary chilled water and condenser water pumps. Now, to do the study, we had to look at the construction carbon footprint, which is how much embedded in that plant itself, in that building. The direct carbon emission via refrigerant leak, which is the at operation and disposal. The electricity consumption as indirect emissions, how much electricity was required and how does it affect it does have a carbon footprint. The water in Gulf might be different from Europe. In some areas in the world, water doesn't have a carbon footprint. Now here, it is produced from desalinated plants. I heard some people are saying this is a byproduct, it's a free, available, but you know, we don't agree fully with that. Still, it has a carbon footprint. The water that we are consuming in UAE, it does have a carbon footprint. Also, there are some other items which are chemicals, bleed off, maintenance, and we found that to be negligible. We started with a chiller here. The chiller, when we look at the chiller, you have the raw material which is used. It can be the copper tubes. It can be the steel, plates, the refrigerant. Anything you use in that chiller is considered there. You add to it the manufacturing, and then you transport it to the site, and here you have the total embedded carbon. Doing that with the exercise that we have here, we found that the raw material were the 75% of that. Why? Because you have the copper tubes. It's coming with to produce copper. You need to use a lot of energy. This is why I think part of Masdar they were looking at reducing the amount of carbon and aluminum used in any items. Then you have the transport. The manufacturing surprisingly was low, 6%, and the transport was a big issue because when you ship from on the sea, it takes you're using a lot of energy, and therefore you're using carbon. You're emitting carbon. So here we have the so now, to do that properly, when we look at the refrigerant, there are two types of refrigerant commonly used in UAE. You might have another 5% absorption or anything else. But for centrifugal chillers, you have like 60% in our medium pressure refrigerant, which is 134A, and 40% are low pressure refrigerant 123. And each one has different characteristics, and each one has its own performance criteria and leak rate. Now, we have added 30,000 tons, and we found out the refrigerant charge used in 123 is much less. The leak rate, historical, is lower, plus the global warming potential of the low pressure is around 76 compared to 134A at 1320. This led to the carbon emission of due to the use for 25 years of refrigerant and with the disposal of 134A to be 25,000 tons of CO2 compared to negligible amount for 123, which is 200 tons. Now, even if you somebody might argue about the losses in 123, they might say no, it should be double, or whatever you do. If it is 200 or 400 or 600, this is still negligible compared in our study. Now we look at another important aspect. This is the chiller operation indirect emissions. which means this is electricity. We have 30,000 tons, and the yearly total electric consumption in kilowatt hour is around 63 million kilowatt hour per year. For 25 years, you have 1.6 trillion kilowatt hour. At the base CO2 emission of 0.577, this is based on combined cycle turbines used in Abu Dhabi. You will have around 900,000 tons of CO2. We do the plant estimate. The plant estimate using the same criteria. It's around 1 kilowatt per ton. You will have a total of 1.3 million tons of CO2 for 25 years. Now, in addition to that, you have the water. As we said, water in GCC, it does have a carbon footprint, and we need to watch for that. Using 30,000 ton with the normal 4,000 hour operation per year, we reach a total make-up water of 17 million. Now, some people might argue plus or minus on the cooling tower, it can be 18 or 16. At the value of 3.256 kilowatt per 1,000 liter, as we got it from the internet as applicable to GCC, desalinated plants. We have around 56,000 tons of CO2 for 25 years. Again, now here we're summarizing and showing the 1, 2, 3, the chillers which are using low pressure comparing them with the chillers with medium pressure. We look here, the major, if we look at the embedded, it's negligible in both cases. It is 90.2%. So if you want to look at reused copper or recycled copper on the chiller, it does not give you a good result for the plant. Maybe it will show a good product as green, but at the end it does not give any significant value. The major one in both cases is the efficiency, is above 90%. It constitutes 90%, more than 90% of your carbon emission, of your carbon footprint of your plant. Next to it, it is the make-up water. It's around 5.6% or 5.7%, depending on which one. So number one is electrical power. Number two is the water. Number three, if we look here, it is the refrigerant emission in case you're using 134A. So what's important for the overlife of a chiller? It's of course the electrical energy used. As we said, then you have the make-up water or for the 1, 2, 3. If we move to 134A, then we have the refrigerant emission are also, they are not quite high, but they are 2.6%. They need to be looked into. This is the plant summary. If we look at how much carbon footprint of the plant is 1.4 million ton of carbon, over 30,000 tons. You can use your own calculation. It's around 30,000 tons, around 4.45 or 46 ton per ton of refrigeration. This is equivalent. If you want to offset if you have such a district cooling plant and you want to offset it, you need to plant 5.6 million trees and keep them for 25 years. Now, we found that the power is the most important aspect. How to reduce it? We have many ways. First of all, you need to start with looking at the most efficient chiller. I say chiller and also the pumps, but the chiller constitute 70% of your power. So you need to concentrate on the right selection for the chiller. Try to avoid titanium or copper nickel tube. We all know that copper nickel and titanium will last more, but over the lifetime of a chiller, if you're putting 7 or 8% more kilowatt, because they are less, they have less heat exchange capability than copper, please try to avoid them. You need to optimize your components, of course. Try to reduce use low flow. You need a brain for the plant. You need an intelligent system. You can use strategies and chilled water tower optimization to have an efficient system. And another important aspect is you need proper and preventive maintenance. I highlighted 2 aspects here that we look into, the chiller and the preventive maintenance. We'll go quickly through them. This is a typical curve. You can ask any of your equipment suppliers to give it to you. Normally, if you leave it to the contractor, you get that point, 0.67. Now, if you want to do something in middle, you don't have too much money to spend, you can go to 0.616. And if you go to below 0.6, then there is a big difference. You're talking about more than 10% difference between the 2 selections. So we have a case where the owners, the district cooling companies, before they finalize and they start producing the chiller, they ask us, do we have any other option? And we propose to them and they study. Does it make sense? Does it pay back? One more important aspect in maintenance, if you have the most efficient chiller plant and you don't maintain it properly, your approach will be higher. You're on both evaporator condenser. Your refrigerant might be a little bit less than expected. You can lose up to 15% on your design condition. So if we have a capability to reduce your district cooling plant by 10%, what does it mean for you? It means your power consumption reduced by 225 million kilowatt hour per year for that 30,000 tons. It means there is a reduction of 130,000 tons of CO2, which you can go to the market and trade it for time being for $2 million. More than that, at Dubai rate of 40 fills per kilowatt hour, you're saving for your own $24.5 million. That's it, $26.5 million saved. This is 3 times cost of the initial price of the chillers. Sorry. If you invest $2.5 million to get that, this is a good payback. So you're gaining twice. You're showing that you're environmental friendly company, you're green. At the same time, it's good for your bottom line. So, in conclusion, for district cooling plants, don't waste too much time. Electric power is the biggest contributor. It's more than 90%, whatever happens. The embedded carbon, it's very negligible. It's around 0.2%. The refrigerant emissions, negligible for 123, more important for 134A, noting that everybody should be responsible these days and contain the refrigerant in the plant. So concentrate on the plant efficiency and invest in efficient systems will deliver a good return.
Thank you. I think carbon analysis, carbon measurement are one of the most misunderstanding things that people actually really tend to, because they don't understand how to measure CO2. What is it? How is it measured? Where is it at in the building? How is it applied? And there's so many applications of CO2 carbon measurement and knowing where you're at. It's like counting the carbs that you eat. If you went to McDonald's or went to, I don't know, Costa Coffee, you count the carbs that you eat. That's the same thing that we do in this industry, is we count how much carbs we're using. How lean can we get this machine to go? And I think it's rather important to do that. Someone told me from Masdar, they said there's only one country that's doing it out of any other country is population control, and that's China. China's the only country that I know of that does population control, where you can't have children, or you got to have a permit to have so many children, or whatever that might be. And that's a big emphasis, is that population growth. The more that we grow, the more ambient temperatures, you know, the more people, the more carbon, the more emphasis on everything. So, thank you for the highlights. Any questions, please? Got a question back there?
Thank you for the presentation. Actually, you have touched on a very good, aspect of emissions and carbon footprint. Now, I'm wondering now, everything is really clear to us now, but I'm wondering, what's the future of 1, 2, 3 refrigerants? I mean, the future, phasing out, because we have protocols that we have to comply with. Now, 134A, the way I see it, is way consuming too much carbon, in a sense of operation and life of the project. So what's the future of 1, 2, 3? Why it's been phased out? It's going to be phased out.
I think the question was about refrigerant, that why the refrigerant are phasing out, or... Now, here, the study that I have done is, it shows that the most important aspect you need to look at is energy efficiency. You have refrigerant will come in and will come out. In 5 years' time, by 2020, you will not see the refrigerant that we are comparing here. You'll see new refrigerant that are more environmental friendly, but as you see, the drive is efficiency. We have seen in many presentations, the drive for refrigerant is to have the most efficient one. This is an important aspect. So, again, the refrigerant that you are using in your plant today will be available till end of the chiller life, whatever it is. If it is the low pressure, medium pressure, even we have seen R11 available in Sharjah, and nobody wants to buy it. So we are not worried about the availability. In fact, it's important to use the refrigerant responsibly. This is the most important aspect. But for the environment, we see that the energy conservation will affect the environment much more than anything else. And the refrigerant, as I said, 134A, 123 will change, but it means for the existing chiller, you continue to operate without any problem. There will be we don't expect any problem with that.
Okay, do you think 1, 2, 3 it will be, not phased out, or is going to be alternative refrigerants coming up to replace 1, 2, 3?
What we are saying is HCFC 123 is available till today as per Montreal Protocol for service till 2040. Now, 134A, there is no limit on it, but there is a big pressure on it because of global warming. And there is a phase down, there is cap and trade in Europe, there is a phase down, there are a lot of pressure on it. And the new refrigerant 1234YF is already coming up. So what I'm saying is, by year 2020, you'll have 2 or 3 new refrigerants, which today I don't know which are they, but 1234YF will be the major one for medium pressure. There is another one for low pressure. But for time being, you can use 134A or 123. Both are good for time being, without any problem if you use them responsibly. Concentrate on having an efficient system. This is good for the environment.
Thank you. Thank you. We've finished with questions, huh? Let's move on. Okay, thank you.
Thank you.
Last but least, we leave the last for the favorites, right? Everyone's favorite here, I'm just saying because he's last, right? Professor Bassam, who's a green retrofitting and the critical step for greener Earth. And I'd like to just briefly go over his bio. Professor Bassam is currently assigned as the Dean of Faculty of Engineering and IT, as well as the Atkins Chair of the Sustainable Design of the Built Environment Program at the British University in Dubai. He holds a PhD in Mechanical Engineering from Ohio State University. His 20 years of post-PhD career include industrial educational research and administrative experiences. He was awarded several international scholarships. He held several positions, including Professor of Mechanical Engineer of Jordan University in Science and Technology. Professor.
Thank you very much. Good evening, everyone. This is it, the last presentation of the last day. I thank you all for staying up with us, especially the ones who are still awake. I'll try to make this thing easy, quick, so no one else will go to sleep. My name is Bassam, and my presentation is slightly different from what we've been hearing all along. We've been hearing more about the technical aspects of HVAC and air conditioning systems, how we can make them more efficient. My point, my take on this is actually on the other side. We're looking more on the demand side. We're trying to see how we can make things greener by reducing the demand for air conditioning system and energy in general. And the picture I've shown here basically shows what looks like the ideal green building. This is what everyone is actually trying to talk about nowadays. The problem is this nice little green building is surrounded by a lot of older buildings, which are highly inefficient and fairly destructive to the environment. So, a lot of you have seen these graphs sometimes in the past. What we show here is basically the amount of energy usage in the world. As you can see, it's clearly growing since the 1900s until nowadays, and it doesn't show any signs of slowing down. On the other hand, the red line actually shows us the energy consumption per person. Luckily, since the 1970s, this line has tended to stabilize, meaning that more people are becoming more aware of the issue of efficiency. We're beginning to implement more regulations that promote efficiency, thus stabilizing the energy consumption per capita, per person. The problem is the overall energy consumption continues to go up. That is because the population of the world continues to go up. If you look at this figure, again, total energy consumption, and look at the figure here of CO2 emissions in the world, you can see they're almost identical. Again, this is a clear indication that human activities are the ones that are responsible for this growth in CO2 concentration in the world. Energy, more specifically electrical energy, is responsible for about 85% of that CO2 emission. So again, anytime we can reduce the demand of this energy, we should be in a better shape in order to save the world. So, what can we do? We can continue business as usual, and we have a lot of people who are still doing that. They don't care. Say, okay, there is a problem, I can't do anything about it, so I'll just go along and do whatever I can. The problem with that is that we will soon run out of resources, and we will do uncontrollable, we will run out of resources, and essentially we'll do uncontrollable damage to the environment, which we cannot recover from. The other possibility is to try to find more energy resources. And again, that's a problem, because we've already exploited most of the energy resources available. We see that nowadays they're beginning to search for oil under the ice caps or down deep in the seas. But that will only solve our supply problem in terms of energy, but it will not solve the destruction that this energy is causing to the environment. The other thing we can do is we can try to reduce the number of people. Remember, the total energy consumption was energy per capita times number of people. And I'm not going to comment how you can do that. Last thing that we can do
is reduce energy consumption per capita. Of all the other options, this is the one that is actually more doable. This is the one that we can actually do, because we have the technology, we have the know-how in order to try to do it. All we need is a little bit more, let's say, political will and education, awareness of people in order to go down that route. Other than that, I don't see any other solutions. If you have any, please let me know. Just as a reminder, the last thing, a lot of you heard about the Kyoto Protocol. Kyoto Protocol is already expired. The next step was supposed to be the Copenhagen 2010, in which the regulation was, or the intention was, to reduce rise of temperature of the Earth by 2 degrees by the year 2050, essentially reducing carbon emissions by 80% from the baseline of 1990. Now, reducing it by 80% is a huge number. That's one thing. The other thing is they don't say how they're going to do, what are they going to do between now and 2050. You can continue, according to Copenhagen, you can continue as you want, as long as by 2050, all of a sudden you switch, you flip a switch, and your CO2 emissions just go down. In this, we're focusing mainly on buildings in this particular presentation. You've all seen some of these numbers before in previous presentations. Buildings use majority of the energy, about 40 to 50% of primary energy, compared to transportation and industry. They also produce around 40% of the CO2 emissions, compared to other factors. I'm not going to stay long on those since you've seen them before. The important thing is to find out how buildings use energy and the concentration. This data is based on summary of houses in the US. You can say that HVAC uses about 31% of the total energy in buildings, followed by lighting, 40%, and water heating, about 9%. Essentially, these three items use up more than 50% of the energy in a building, which is good and bad. Bad because you use a lot of energy, but good because if we focus on just these three items, we can actually contribute significantly to the reduction of energy in buildings. And this is basically what I'll be talking about during this presentation, is how can we make this thing happen? And how we can make it happen for older buildings. That's the thing. Most people are only focusing on new buildings, but if we forget about the older ones, it is a problem. Just as a summary piece of information, in Dubai, HVAC systems use about 40% of the electricity produced over the year. And during summertime, they can actually consume up to 60% of peak power. So again, there is a lot of infrastructure that needs to be put in if we continue to increase the use of HVAC systems. Another issue we have is urban growth. More people are moving from the countryside to urban areas. Last year, we actually hit a milestone, because last year we had about 50% now of the population living in cities. Before that, more people were living outside the cities than in cities. Now we can see a steady growth, and we've hit the 50% mark last year. And this is expected to continue to grow, reaching up to 75% of people living in cities. Again, that will put a very heavy stress on the existing infrastructure, which means that you have to upgrade your grids, you have to upgrade your power plants, you have to upgrade your roads, water systems, sewage, all of that, unless you can reduce the consumption of per capita, thus allowing more people to come in, but still be able to use the same infrastructure as before. The other thing that is important in terms of urbanization is that more and more older houses are being used for longer periods. We cannot afford to continue to build new buildings for people as they move into the cities, especially now in these economic situations where things are becoming even tougher. You'll find that less and less new buildings are being built. More older buildings are being used for longer periods than they were supposed to be in their expected life when they were first built. Some even buildings converted into residential type housing. So if we have to deal with this, it's a problem, because these buildings, which are supposedly old, outdated, and should have been knocked down and replaced for something newer, more efficient, will continue to live on for longer periods. It's a problem, but again, it's an opportunity depending on how you look at it. Okay. Focusing the greening efforts on urban areas can actually also maximize the payback for, because you have a small region, small concentrated source. If you focus most of your energy on it, you should get the maximum return rather than spreading your effort over a wider area outside the city. Okay. As we said, most of the focus is now on new buildings. All the new regulations, assessment techniques are focusing on new buildings. If you look at the case in the UAE, we're actually well behind the world. In 2003, that was the first time that Dubai municipality declared Decree 66, which basically talks about the insulation and the need to put insulation. That was the first step, if you want to think about it in terms of more efficient buildings or greener buildings. It wasn't until 2010 when Dubai municipality released the new revised green regulations. But remember, they are voluntary. So this means that you don't have to do them if you don't want to. And at this point in time, unfortunately, there is no incentive for anyone to do them. Only Abu Dhabi has put in 2010 istidama and made it a regulation, made it forcible, something that everyone had to do at least at the 1 per level, which is a step in the right direction. You can't put a system out and just have people say, okay, this is the system, do it or not, regardless whether you do it or not, we're not going to give you anything extra or any bonus. So the voluntary type of systems, I don't think is the right thing in the long run. We have very limited time frame in order to adjust our way of living, and we cannot wait and use the voluntary system to do that. Excuse me. Okay. Buildings, new buildings are being added at the rate of 0.5 to 2% per year. This is an average around the world. Okay, so that shows you how many new buildings come online every year. The problem with that, it means that almost 70% of the buildings that will be there in 2050 have already been built. This means that by 2050, we'll have 70% of our buildings totally inefficient, built to antique regulations, and do not have any sources of energy efficiency in them. This is a very problematic issue because if you remember the Kyoto Protocol that says we wanted 80% reduction of CO2 by 2050, this means because of the 70% old buildings that we have by 2050, every new buildings from now on have to be zero carbon or even negative zero carbon in order to achieve the 80% reduction target, which is totally unachievable. Okay? Thus, the only way we can actually manage this problem is we have to go back and look at the existing building, the old stock, and we have to be able to go back and refurbish it, improve it, upgrade it, enhance its efficiency and energy consumption. Some countries are actually beginning to, think about incorporating regulations for existing buildings and upgrades. I think Dubai municipality and Abu Dhabi are thinking about this by 2014, 2015, to have regulations for existing buildings that they will ask people or force people in order to upgrade their existing buildings in order to make them more efficient. Just as an example, in the UK, if you reduce the CO2 emissions of buildings by 25%, essentially make them 25% more efficient, it's like taking all the cars in the UK off the roads. Imagine, can you take all the cars in the UK off the roads? Not possible. But by improving the efficiency by 25%, that is the equivalent in terms of removing CO2. And we'll see later on that's actually very achievable. Improving the efficiency by 25% is quite doable. As I said, in order to do this, we need to focus on the main components: HVAC, lighting, and water heating. Okay? We need to use efficient buildings with tighter envelopes, insulation, glazing, moisture barriers, high efficiency HVAC equipment, and there's again another opportunity, let's say, for refurbishment of old buildings in terms of their air conditioning systems. If you drive around, you'll still find a lot of buildings that are still using window type air conditioning systems. Can you believe the amount of energy being used there for air conditioning purposes? So essentially, you can cut down the energy consumption by a quarter, by 75%, down to 1/4 if you use more advanced energy conditioning systems. Reduce artificial lighting and basically try to rely more on efficient lighting and or incorporation of natural light. Use free resources for water heating, example, solar water heaters. It's very interesting that in a land where we have plenty of sun, we very rarely use the sun in order to heat our water. Most people say we don't need water heaters. I don't know about you, but when I take a shower in the morning, I do need a water heater in order to be able to take my shower. So why use electric heaters if you can get something for free? Develop basically all what we can do, and we can do all of this using proven, mature, and easy to apply technologies. We don't want something fancy. We don't want something that will sound complicated or will be complicated or will be very expensive. We're looking at techniques and practices which are well known, easy to apply, and at the same time economical and can provide the results that we want. Now, these are some of the benefits of green buildings. I'm not going to go through them. You've heard them in several formats before. So, where do we start? Look at basically our buildings. Sometimes if you look at a row of buildings, you can think that they are all the same, but looks can be deceiving. Look at the thermal imaging of them. You can easily find that there are some buildings which are worse than others, some buildings which are inefficient. We can use something like this in order to find out where we lose our energy in our buildings. You can see the main losses actually occur from the roof, as well as the glazing in the buildings. So this is the area that we need to focus on in order to improve that. If we talk specifically about the UAE, a recent student, a master dissertation student of mine has completed her dissertation, and I'm just going to put just a sample of her output. Essentially, she did a study of the different buildings in the UAE over different periods that were constructed in the 70s, 80s, 90s, 2000, 2010. And she looked at the average energy consumption of a single family home. Look at the buildings that were built in the 70s up till 1990, because between that there was no changes in terms of regulations. Energy consumption is upwards of 300 kilowatt-hour per square meter per year. Compare that to what is required by the new regulations, whether they be Dubai's or Abu Dhabi. You're talking about the 100 kilowatt-hour per meter per year. Essentially, 3 times as much energy as the buildings should be using if they're designed according to the current regulations. So there is a lot of room to save energy. We can't say that we can bring them all from this level to the same level. But if we can save half of that, that will still be a significant contribution. The other thing to note is that these numbers do not actually take into account that older buildings are actually deteriorating and degrading. The more the building degrades, the more it will use energy and will become even more efficient. Another case study, which was also important, talked about retrofitting, happened in Kuwait. In there, they saw the effect of adding extra insulation to the roof, reduced energy by 17%. Adding extra insulation to walls, you end up with 25% energy reduction. If you also change the glazing, you can get another up to 17%. So essentially, an optimized refurbishment of a building resulted in almost 50% reduction in energy. Remember the one that we were talking about in the UK? It says just 25 will give you taking all the cars off the road. We can easily achieve 50 by passive techniques. Okay? Cost-wise, insulation is the cheapest. So basically, in terms of saving versus the amount that you invest, that is the cheapest one available. How do you add insulation? Actually, insulation is fairly easy. It can be added externally, it can be added internally, and it can actually be done within the wall itself. We have some older type designs where you have cavities in the wall. You can actually fill those with foam material in order to increase the thermal efficiency and thermal resistance. And the added advantage also is that most of these materials are actually fire resistant. So not only you're improving your thermal resistance, you're also improving your fire resistance. Natural insulation like green roof, green walls, again, these have been put into some of the regulations here in the UAE. I'm not going to talk too much about them. but they do have a significant number of side effects which are fairly useful to the environment. One thing you've probably heard about recently is insulating ceramic coats or paints. All of these claim that they can use ceramic coats, basically an additive to paint, in order to reduce energy consumption, increase the insulation capacity of buildings. All of them say that this is based on NASA space technology, whatever that is, I don't know. Some of them talk about a single layer, some of them talk about multiple layers. They claim energy efficiency or energy reduction up to 50%. Unfortunately, I have not been able to see any scientific proof of that. So if you take the word of the manufacturer, that's one thing. But I like to stick to independent, verifiable results. And until now, I have not been able to see anything that will show this amount of saving could be achieved. Glazing, you probably all know about that, is basically changing, most of the time using single glaze, use double glaze or triple glaze, using reflective coating, sometimes even the gas fill between them. All of that can have significant impact on the energy consumption. And I see that I'm already down to 0, so I have to run through this a little faster. Essentially, there are also solutions now that you basically can retrofit windows fairly easily. You don't even have to change the window itself. You can just add an extra layer to the outside of the window and basically contribute to the energy savings in that one. Lighting, you all know about the different types of light. Luckily, we've already started moving most of our buildings into fluorescent type lighting, although there are still some which are using incandescent light. But LEDs are becoming probably the next generation, but they will not be economically feasible, I think, not for at least 5 to 10 years from now. So the next step is to try to see if we can incorporate some natural lighting. Unfortunately, I find most designers do totally ignore natural lighting. When they're designing their buildings, they just think about artificial lights and do not think about using natural lighting in whatsoever way. These are some examples of natural light, and this building is actually in Dubai. It's the Lagoon Sales Center, and all of these lights that you see are actually natural light. They're using light pipes. You capture the light and basically you pipe it into your building, and so you have natural light free. Light shelves, again, another important application. They perform two functions. For one, if you look on the outside, they're actually providing shading from direct sunlight. So you reduce your solar gain. At the same time, they're taking the upper part is actually channeling some light deep plan into your building. So again, you can get natural light deep plan without having to use artificial light. All of these things contribute to reducing your energy consumption. An important thing to note is that this is not the end. When you start refurbishment, that's only the first phase. It's very important to follow it up with regular maintenance. And this is something that we are totally lacking. We lack regular maintenance, replacement of filters, sealing of cracks. All of these are things that need to be kept up with on yearly basis, because it doesn't matter how good your equipment in the beginning, when you first install them, if you don't maintain them, they will quickly degrade and you will lose all efficiency that you have put into it. These are just some examples of that. Note that in this presentation, I did not discuss any of these things, which most people tend to talk about. These are the high-tech stuff. These are the stuff that most people would like to talk about. But the idea was to keep things simple. I wanted to show that green doesn't mean paying a lot of money. Green doesn't mean making life difficult. Green doesn't mean it's technically challenging. You can still become green at a reasonable, to a reasonable extent with simple procedures and simple applications like we have seen before. How to promote green? I think this is an issue, how to promote green refurbishment. If we cannot promote green buildings, new buildings, how we can promote even green refurbishment? It's a problem. The two paths are easy. One is economic incentive. If we actually pay more for our electricity and water, if we pay true value for electricity and water, then it would be economically viable in order to invest in something like this. The other thing is basically regulation, is if we try to force people to upgrade older buildings. In the EU, they have modification, any modification of a building more than 1,000 square meters will require you to actually refurbish the older part. So basically, if you trying to upgrade an older system, you have to upgrade even the older parts before you add a new extension to it. Thank you very much, and if you have any questions.
Any questions?
Okay, there is a gentleman also in the back. Well, we can start here until the mic gets to him.
My question was, you made a comment on LED not being viable for the next 5 years from an economic standpoint. Is there any?
I think it's just the cost. It's still expensive. I mean, the technical know-how is there, manufacturing is there. It's that the cost is still fairly high.
Very interesting because we as manufacturers, we are into LED lighting in a big way. And there has been a study done over the...
Excuse me, can you have your mic on? So they,
I actually removed the mic, I'm sorry for that.
This one here?
just rather quickly here, we'll close up.
Yeah, the question is on the observation of Professor on LED lighting, that it's not viable economically. Now, we are manufacturers of LED lighting, and we have also done some extensive study through research companies. And between now and 2015, over the next 5 years, they're expecting in the lighting industry, the shift is going to be heavily into LED lighting. And the market is sized at about $110 billion. 55 billion of that is going to be LED lighting. Primary drivers being the mature markets of US, the Americas, and the Western Europe. So that's the reason I raised this point.
As I said I don't see it becoming economical within 5 to 10 years. Actually, before I came here, I was in a meeting with a guy in Philips, and he was also talking about LEDs. The problem, as I said, technically it's there. Now, the economic viability actually depends significantly on where you are in the world. Again, if you are in a country like the UAE where electricity is cheap, it's going to take a long time before they become economically viable. But if you go to a country where the electricity is expensive, then economic viability will occur at a much earlier stage. That's the way a lot of people are actually doing it, is taking out the subsidies and investing them into new technologies in order to... Actually, it acts as a safeguard for the future. Because if you save energy now, you're less susceptible to any fluctuations that might happen in the future. But if you continue to rely on the issue of subsidies, then basically you're throwing money down the drain.
Do you have one more question out there?
Yes. Thank you, Professor, for the presentation. Actually, we have a good combination here. Actually, we have the academia and we have the manufacturers. I have a question now. Why don't we go back to very old technology, which we don't see now, which is absorbent chillers or absorption technology, let's say. Now, we have a small capacity scattered all over, especially in residential areas. Why don't you combine solar and absorption in these small dwelling units? I think this is a very, very valid issue, and it looks like it's been ignored by manufacturers, it's ignored also by academia, and I could not see it in upcoming research. So I need this answer from both, from you and from the gentleman.
Solar absorption air conditioning is, as I said, an interesting issue and an interesting topic. And we're actually beginning to do some research on it. But again, the topic of this presentation, as I said from the beginning, is looking at simple technologies that can be applied immediately without having to wait for huge investments, huge developments in terms of technology. Solar air conditioning is actually a very interesting topic, especially in an area like here, where you have a lot of sun. And the interesting thing about solar air conditioning is, unlike most mechanical air conditioning systems, mechanical air conditioning systems, as the temperature outside goes up, the efficiency goes down. Correct? Okay. I didn't forget my basics. Most of the time, okay? On the other hand, solar air conditioning systems, the higher the temperature, actually the more efficient the system becomes. So the capacity actually goes up rather than go down. So it's a very good system that matches the outside conditions. The thing is, it still requires some technical development. Cost-wise, initial investment is still much higher than that of a regular air conditioning system.
Okay, why the manufacturers not looking into this? So, I mean, we are focusing in refrigerants and so forth, where we are not really focusing in natural, which is sustainable energy, which is free of charge, and we can utilize.
As I said, it all goes back down at the end to economics. If electricity is cheap, it's much cheaper to put an electric-driven air conditioning system than to invest heavily into a solar system. If the electricity becomes more expensive, there might be an economic case for putting in solar. If that's not the case, then people either try to put it as a show-off, or because regulations forces them to do something like that. Other than that, it doesn't work. Unfortunately, a green world doesn't run without a green dollar. Okay?
Thank you, Professor. I think that will conclude. We have one more speaker, I believe, with Carrier. But one thing that I'd like to highlight about the professor's presentation is the demand loads that are given for these buildings throughout the GCC. You know, you'll have a grid system, and then the demand load from, you know, could be the Abu Dhabi authorities or DEWA or whoever it may be from. They have a certain load, and that's the load you're going to get. If you want to go under that load and set your building under those parameters, you're still going to get that load because it's an assurance for them. It's the way that civil defense is set up for the majority of these buildings. So a lot of it is that you got to customize your building, but whatever load that they give you could be more than what you really need. So that's something that the utilities companies would have to start to analyze to say what service loads that you need for the building and what, you know, safety requirements for those services may be. Because refrigeration, as our Kuwaiti guest had mentioned, that's one of the most primary factors. You can have your mobile phone, you can have your car keys, and you don't know where your children is, and you don't. But if you lose your AC, that's serious stuff. So.
Can I comment on that for a minute?
Please.
Actually, what you have said has been done in Qatar. You know the Pearl development?
Yes.
Okay, now the Pearl development, what happened is the major developer decided on the maximum load that each plot can actually have. And that forced by the designers to actually design for very high efficiency buildings because now they don't have enough electricity to run their regular air conditioning systems. So that they had to rely on much more efficient designs in order to be able to meet their requirements within the cap that was imposed on them.
Fantastic, fantastic. Excellent. Well, let me we have some honorary awards for you gentlemen for doing such a great job through the years. And I'd like to bring you up, yeah? Yes.
Okay, I recognize I'm the last speaker here, and anyway, let me introduce myself, okay?
Please do. Thank you.
My name is Prashant, and I take the opportunity of talking to you today on two counts. One is because I represent Carrier Corporation, and the second one is being the past president of ASHRAE Falcon chapter. So on both these counts, you know, I want to congratulate ASHRAE Falcon chapter for giving Carrier the opportunity to speak last. Why? Because two things I've remembered while traveling abroad is when you enter into an airport, when you give your bag, last one comes first out, which means that what I speak today, you are going to keep it in your brains and go home. So let me talk here. Today was given the opportunity for me to say Carrier word. Now, word of Carrier is very important, and for me, Carrier word has got a lot of words in it. Now, I want to take also to mention here that we were given the opportunity to present ourselves at the Kuwait conference. It happened in April, and where I also was part of it. And our engineers were also there from the Kuwait University and from the Ministry of Electricity from Kuwait, where we were asked to present the case on refrigerant issues for the Middle East environment. So Carrier came up with a presentation there, and I want to share some few. I want to skip through many of the presentations here because all of them have been discussed. But the only thing is I want to take it to the last one, which will allow me to spend about, let's say, 2 minutes on end of the session for a video presentation and 8 minutes together for the Carrier paper which was presented at the event. Now, I'm going to skip all these things because this has all been covered by many of the presenters. This has all been discussed. This is all the regulatory protocols. Everybody is aware of it. So this is what we talk about, the Montreal Protocol requirements, the Kyoto Protocol requirements, and the refrigerant transition. All of them has been discussed, so I will not take much of your time because we are already late. Because I also happen to be the ASHRAE Board of Governors, so I want to recognize that today is being the last and we are short of time. So I'm going to skip these things. Now I want to come to the point where carrier were asked to present their position. So the position that came out of the event which happened in Kuwait was that on the Middle East environment, on the temperature, on the refrigerant issues, carrier strongly supports environmentally sound solutions that eliminate all HCFCs for new equipment and at the same time improve system efficiencies. As such, carrier is in agreement that all HCFC 22 and HCFC 123 in new equipment should be phased out over the coming 5 years. Carrier sees HCFC 134A as the best current refrigerant solution for large screw and centrifugal chillers, and HCFC 407C as an ideal solution for window air conditioners, split air conditioners. For all other applications, for example, the split air conditioners and rooftop applications, carrier sees HCFC 410A as the best current refrigeration solution. Carrier sees a 5-year transition period in being sufficient to migrate all new equipment production from HCFCs to HFCs. We are well aware of considerations to reduce HCFCs due to high global warming potential. However, it is important to note that 85 to 95% of global warming from a typical air conditioning system will come from electrical energy, that is indirect, while the rest of the term comes from the indirect ways is through emissions. So present and future carrier equipment products will be more efficient, meet or exceed the current ASHRAE 90.1 standards, and will be further improved as the standard is modified. Thus, more efficient products will reduce electrical power usage and thus global warming. Now, what came out of this ASHRAE conference in Kuwait and what observations we noticed as carrier, I want to talk about a little bit here. The ASHRAE method of measuring efficiency is EER, based on net capacity, which takes into full account the system integral losses as well as fan and motor inefficiencies. While the kilowatt per ton rating method used by some of these Gulf countries, and especially Kuwait, for example, are based on gross capacity. And that does not fully account for all system inefficiencies. That is observation number one, which we noticed it. The second observation we notice is the new high efficiency systems utilize larger outdoor coils and consequently improve high ambient performance. The EER of these new systems at 35 degrees centigrade is representative of average Middle East year-round performance. Ineffectively, this is an equivalent SEER for our region. So what it means to say is that, as long as a unilateral approach is taken within the GCC countries to use the ASHRAE 90.1 EER as a standard, and then you use your degrading effect based on your high ambient, could be a good measure. That is what we have noticed there. And observation 3 is carrier has a concern with different standards for each unique country market. It is difficult for manufacturers like carrier to test hundreds or more different HVAC products at conditions that are satisfy different standards in several different countries and to have independent lab certification for all these different standards. So we would urge that all GCC high ambient countries unify and adapt by reference to ASHRAE 90.1 with EER at the 35-degree rating point as the measure for overall equivalent SEER for high ambient. We recommend that equipment should also be tested at 46 degrees centigrade to demonstrate that it has good performance even though the EER is greater than 6 at 46 degrees high ambient conditions. So finally, the word would be that carrier R&D centers around the world, as along with the United Technologies R&D Corporation, are continuously working with the compressor and refrigerant manufacturers to develop next generation products. Now in the future, carrier will have the right refrigerant for every application, but not every application may not have the refrigerant solution. So with this few words which came out of this ASHRAE conference in Kuwait, this was a position paper which was presented there. I want to take you around for a short video presentation on carrier.
I don't think we have that time to do that right now. I think we have,
do you have time? No?
Awards that are coming up.
Okay.
So we're just cut really short with this.
All right.
So if you can, we would like to just send the awards out to you gentlemen now. And if could you help us with maybe awarding these gentlemen here?
Yep.
And
thank you, gentlemen. Thank you very much, for giving us the opportunity here. Thank you.
Okay, I guess we can start with our first speaker that came to the session. Thank you very much. He's with Samsung.
Thank you,
Mr.
Madam. Thank you
Madrid.
very much. Nice meeting you here. Thank you. Thank you.
Mr. Alexander Ward, please.
Thank you, Mr. Ward.
Then
Thank you
Mr.
very
Albert
much. Thank you very
Heiko.
much. Thank you very much. Thank you.
Thank you for your great support. Albert. And,
Thank you, Albert. Thank you very much. Okay. Thank you very much. Thank you. Hey.
and Professor Bassam, please. Come on, please.
Thank you, Professor. Thank you very much. Thank you very much. Thank you, Professor. This is for you. Thank you.
Thank you, gentlemen. And that ends our conclusion for this evening. We do have UNIP will be coming to the stage for events, but after that, I think there's a closing with the ASHRAE members outside at the coffee. So let's take a break and talk about it. Thank you.
شكرا جزيلا. طبعا احنا ايضا بدورنا نشكر أشري لكون للتعاون الكبير بيننا وبين أشري. هذه تمتد لفترة طويلة، وطبعا انه الاخ الدكتور وليد ما قصر يعني في كثير من المشاريع اللي هو دائما يدعمنا فيها. فشكرا جزيلا، وان شاء الله نتمنى انه تستمر هذا الكوبريشن ويستمر التعاون بيننا وبين الأشري.
أشكركم جميعا فردا فردا، بدناش نكمل بعدين.
What I'd like to do is, this is the last. We'd like to just congratulate everyone that participated and showed up and congratulated you, make it here safe and make it home safe. Okay, let's put it together. I'd like to first want to give out some awards to all the sponsors that helped us. And Samson, would you please come on up? Can I have Samson come up, please? We appreciate all the support that you've given ASHRAE. Thank you so much.
Daddy, that's my dream car.
Finally, I want to thank Derek. Please.
Oh, thank you.
Okay, thank you everybody, and finally we would like to call Mr. Adnan Istaqan from Samsung for the draw, the raffle draw actually, of one of the laptops of Samsung. Anybody wanted to put the final chance to put a business card? Please. Mr. Adnan, go ahead. Oh, we'll accept from the BOGs also. Okay, now we will request from Mr. Adnan to draw with a blind eyes, with the closed eyes.
And the winner is Adnan Saqan. Sorry, that's my name. Okay. That's Mr. Daramola Oluwasisan. Finally, I would like to thank the organizers of this event, Dr. Ahmed Ala. Okay, you've got offers to buy it. Somebody he wants to sell. Who's buying?
What am I selling?
The laptop.
Laptop? No, I'm not selling.
Okay, congratulations. I hope you're going to be here in the next 2 days. We'll arrange for that. I might bring it tomorrow. I'll hand it over to Rami and then you pick it up from. Thank you very much. Congratulations.
Congratulations. Congratulations to Nigeria.
Okay. Thank you very much. I'd like to thank the ASHRAE committee, the Falcon chapter. I'd like to thank all the audience, everybody for supporting us, and we look for continuous support. Thank you very much.
Can we call everybody to a group photo, please? Anybody interested in a group photo? We are taking a group photo right now.